Welcome to Lasea class. I am your teacher, Jan Lasea.
A blessed day to everyone! Today, we are going to learn recommender system in machine learning. The recommender system is a system that recommends products or services to customers. It is a subclass of information filtering system that provides suggestions for items that are most pertinent to a particular user. For example, a user will buy or like or watch or dislike products or services. This become feedbacks to the recommender system. The next time the user will buy product or service, the recommender system will suggest similar product or service to the user. There are three types of recommender system. The first one is the popularity-based system. It presents options to customers based on what products and services are popular at the time. They will inform you a message something like this. For example, here are this week's best sellers. The popularity-based system does not need machine learning to implement. The second is the collaborative-based system. It makes recommendations based on what others have selected. For example, people who watch this movie also watch these following movies. The collaborative filtering or collaborative-based system approaches build a model from a user's past behavior, items previously purchased or selected, and or numerical ratings given to those items, as well as similar decisions made by other people or users. The collaborative-based system does not need machine learning to implement. The third is the content-based system. It presents options to customers based on the content. For example, if you like the movie entitled Toy Story, you know the whole content or the entire story, you will probably like this movie entitled A Bug's Life 2. The content-based filtering or content-based system approaches utilize a series of discrete pre-tag characteristics of an item in order to recommend additional items with similar properties. The content-based system does need machine learning to implement. The cosine similarity is one of the methods to implement content-based recommender system. Cosine similarity is a measure of similarity between two non-zero vectors defined in an inner product space. It is the cosine of the angle between the vectors. That is, it is the dot product of the vectors divided by the product of their distances or lengths. The formula for the cosine similarity is equal to the cosine theta or equal to the dot product of the vectors, namely A and B, to be divided by the product of their lengths or distances, or equal to the summation of the dot product of the vectors, namely A and B, from 1 to n, to be divided by the product of the square root of the summation of the square of the vector name A from 1 to n and the square root of the summation of the square of vector name B from 1 to n. Let us look at a example code written in Python that will understand more about the cosine similarity. The scikit-learn library or the sklearn has a built-in command that will calculate for us the cosine similarity. First and foremost, we need to import some package library for Python such as the pandas library, the numpy, and of course, the sklearn or the scikit-learn. Next to that, let us declare some vector variables, namely A and B. The content of this array name A contains the ordered numbers 911. The second vector name B, which is a array, contain also the same order of numbers 911. And then let us test if these two vectors, namely A and B, are similar by computing the cosine similarity. We call the method or the function cosine underscore similarity, and then we pass the two vectors or arrays, namely A and B. And then the output is 100% exact replica, or they are exact similar. Another example down below. Suppose, for example, we change one of the values of the vector or array name B. We will change the second value from 1 to 5. So let us compare the two vectors value 911 and 951. So how much is the similarity between the two? It is 92.32%. A score of 1 or 100 means that they are exactly similar or near similar. A score of near to 0 means that they are different. Another example. This time, we change the value of the array name B from 951 to 143. So let us compare 911 to 143. So what is the computed cosine similarity? It is 34.44%, which is near to 0%. That means that they are different. The cosine similarity method or function or command, not only it can calculate the cosine similarity of 2 or 3 values within a vector or an array, it can be more unlimited. Here is an example. For example, the vector or array name A contains 4 values 9110, and then the vector or array name B contains 9513. So if we calculate the cosine similarity, it is 88.66%. Let us have another example. For example, the movie we wanted to recommend, or we wanted to determine if the two movies have similarity in terms of some properties or keywords. For example, in that property keywords, we have these following attributes, such as action, Vietnam, veteran, accused, police, brutality, sheriff, 3D animation. And then we create a panda data frame. The first title of the movie is First Blood, which is the first part of the Rambo series, which is a action war movie. So the following data of that movie entitled First Blood, that the property action, it has a 1 value indicating that it is an action. If it has a value of 0, therefore it is not. So action, Vietnam, veteran, accused, police, brutality, sheriff are all one except the property 3D animation, which is not a 3D animation. That's why we place there a value of 0. The second movie entitled Rambo First Blood Part 2, the second part of that First Blood, here are the following uh, values of that. So action, Vietnam, veteran are all one, but the property or attribute, accused, police, are set to 0. Brutality is 1. Sheriff is 0. 3D animation is 0. Finally, we have this movie entitled A Bug's Life. Action is 0. Vietnam is 0. Veteran is 0. Accused is 0. Police is 0. Brutality is 1. Sheriff is 0. 3D animation is 1, which is a 3D movie. Next to that, we will now test if two movies are similar to each other. So let us first display the contents of each movie. So I wanted to extract the information regarding the movie entitled First Blood and then store it to that memory variable movie 1 and then print it out, and here it is. And then I wanted to compare to the second movie entitled Rambo First Blood Part 2, and then the following printed information of that contains the following data or content. And then if we compare or we want to find out if they are similar, applying now the cosine similarity, we pass the two memory variables, movie 1 and movie 2, to the method or function cosine underscore similarity, and then the computed cosine similarity is 75.59%. So there is a similarity between these two movies. Now, next, if we compare another movie entitled A Bug's Life, and we compare it to the first movie entitled First Blood, first, we will display the content of the movie entitled A Bug's Life, and here it is. And then if we calculate the similarity of the movie entitled First Blood with the second movie entitled A Bug's Life by passing to that call of the method or function cosine underscore similarity, the two memory variables, movie 1 and movie 3, the calculated cosine similarity is very low, 26.73%. That is how the cosine similarity works. The movie content data set contains 4,803 samples. This data set is taken at the Kaggle website. It contains 24 columns or attributes such as budget, genres, keywords, title, cast, director, overview, release date, revenue, and so on. Let us implement a example recommender system applying the content-based recommender system to recommend movies. The following code written in Python is not my original code. I modified this code of Jeff Procisi from his book entitled Applied Machine Learning and AI for Engineers. First and foremost, we import package library such as the pandas library and of course the scikit-learn or the sklearn library that has a cosine similarity and other commands built to that library like the count vectorizer. Next to that, we will going to load the data set given, which is the movies content data set that contains 4,803 samples. And we will going to print the first 5 records of that data set. And then the result of that are the following. It displays the first column of that, which is the index, followed by budget, genres, homepage ID, and many more. It has 24 attributes or columns. Next to that, we will going to select the features that we are going to manipulate in order to recommend movies. The selected features are the following: the title, the genres, keywords, cast, and then the director. So we only choose 5 out of the 24 columns or attributes. Next to that, we will going to check if there is or there are null or missing values or no values using this command df.isNull.sum, and then the result of that, the column or the attribute name genres has 28 records of missing or null values. Another is the keywords. It has 412 missing values. Another is the cast, 43 missing values. And then the director, 30 null or missing values. To fill the missing values, we call the command df.fillNA and then supply now the value to replace that missing value. Here in this case, it is a empty string, not a numeric number, but empty string. By the way, the 5 selected attributes such as the title, the genres, keywords, the cast, and director are all categorical data or text data, not numeric or number. That's why we simply fill it with a empty string. To check if there are still null or missing values, we call again the command df.isNull.sum, and then the result now, we have none missing values, all 0. Next to that, we will going to add another 6 column or attribute, and we will name it features. And then we concatenate or we combine all the 5 that was chosen before, which are the following: the title, the genres, keywords, cast, and then the director. And then let us display the first 5 of that, and here they are. Next to that, we will now tokenize and then count the words or the text so that we can be able to convert those words into numbers. Using now the count vectorizer, a command in the sklearn library that will that will going to count the frequency of the words except stop words. And then the end result of that is that it will create a matrix. So the result of the vectorizing and tokenizing, the result of that will now be a matrix of counted numbers of words. And here they are. The size of that is 4,803 records or rows by 918 columns. And then that tokenize and vectorize text into a matrix of numbers, counted the frequency of numbers, will now be computed using the cosine similarity. And then here are some of the results of the calculated cosine similarity. Next to that, there is a function defined named getRecommendation, that this is the method that we are going to call by and by to determine movies that are similar to that movie that we will test, in order that we can recommend at least 10 movies to the user. The method or the function getRecommendation will accept the input title of the movie watched by the user, and then the dataset, the pandas dataset, and then the computed vectorized frequency or count matrix. And then it will now get the corresponding row in the similarity matrix, and then it will gather 10 top 10 highest computed cosine similarity, and then it will get the title of those top 10 highest cosine similarity. And then in addition to that, I added the calculated cosine similarity so that we can be able to see how much is the calculated cosine similarity of every movie that was recommended by the machine. And then next to that, we are going now to test a example movie that we watched before. For example, the movie entitled A Bug's Life. I watched this movie long ago. So what will be the top 10 movies that are similar to A Bug's Life? So we call the method get_recommendation. We pass these following arguments, and then it will return a list or a vector or an array, and then we implement a for loop statement that will print the top 10 movie titles, including their calculated cosine similarity. And here they are. That Bug's Life, A Bug's Life, the recommended movie similar to that are the following: The Road to El Dorado, which is a cartoon. It has a calculated cosine similarity of 41.40%. And then followed by the following 9 additional movies. Another example. Suppose, for example, we wanted to know what are the top 10 to be recommended by this machine with that title of the movie First Blood, which is a action movie. So the result of that, we have the part 2 of that First Blood, followed by part 3, and so on and so forth, together with their computed cosine similarity. The top one is 56.69%, similar to the First Blood, the Rambo First Blood Part 2. Finally, we will going to know what are the top 10 to be recommended of title of movies to the movie entitled Avatar. And here are the results. The first or the top one is the Guardians of the Galaxy that has a cosine similarity of 55.90%. And the following are the following movies that are similar to Avatar. Is sci-fi, action, drama, suspense, movie like, kind of a like.
That ends our topic for today. I hope you are inspired in my class. Thank you for watching. God bless us.